All right, so site plan, site layout. According to Wikipedia, I found a definition and it says that a site plan is basically an architectural plan that shows landscape architectural documents, and that would entail things like detailed drawings, engineering drawings of the proposed improvement to be given to a given lot, and you would basically have the footprint of the building, which is basically the shape, and it will indicate other features on the property such as your parking, your drainage system, your water lines, any trail, lighting, landscaping, and garden elements, as well as you could have, and it is really a graphical representation of the arrangement of all your buildings, where they would be, and all the landscaping feature and park drives and stuff like that we said earlier. But I have inject something below here in bold to say that just like when we looked at the floor plan, we said that the section for the floor plan is taken above windowsill, and for the foundation plan we said that the section is taken below the floor. Well, for a site plan, it's as if you're looking from about 100 or 2 feet, 100 or 200 feet in the air looking down. It's an aerial view. So you're seeing the immediate property as well as any adjacent property or features or things that pass by the property. So if there's a road, if there's a train line, if there's a river, a bridge, whatever it is, you would have to show all of those things on your site plan as long as it is adjacent to your property. So this is an example of one, which ours will not be as detailed as this one, but just to give you an idea of an aerial view of a property. This one shows some parking lots over here. It has a roadway here. This is the property line. And there is a coastal area along here, a lake. And there's a building somewhere off here in red. There's a tennis court. There is another little house over here. And there's a dog park. So this is really a big lot, big property. Playground over here and stuff like that. But ours now, it's more just unique to where our building will be and what is adjacent to it. So before we start doing any drawing, we'll have to basically set up the units, the surveyor's units. So we're going to come back and do that, but just to say that we need to do that, and we're going to units to do that later on, to assign it to surveyor's units and our precision to the nearest second. So I'm going to be explaining that now. All right, so when we were doing the polar coordinates as one of the coordinate methods, we would have mentioned that angles are measured from east going anti-clockwise by default as positive angles, and if you were to go clockwise, then your angles would have been negative. There is also another system that is used in the azimuth, where 0 degree is at north and angles are measured clockwise. However, we are going to be using the bearing system, which is used for surveyor's unit. So north and south would represent 0 degree, and angles are measured clockwise as well as anti-clockwise from north and south. So you may have heard of angles such as northeast or northwest, southeast or southwest. So what it means is that 0 degrees at north and 0 degrees at south, and the angles are going away from south and north towards east and west. Everybody understand that so far?
Yes, sir.
All right, so it means that the maximum angle that you can have in this system is 90 degrees. So let us look at some typical surveyor's diagram. We'll talk about what that is. But before we do that, we're going to look at how you interpret the angles. So angles in surveyor's units, usually to be very precise, we try to do it not just in decimal degree, where you say like 25.34 degrees, where nobody understands what that means. But we will break it down into what is called degrees, minutes, and seconds. So what I have done on screen is to demonstrate 1 degree, how it is broken down into the different parts. So from 0 to 1, you would have 60 different compartments And each of these compartments represent 1 minute. So we would say that 60 minutes will make 1 degree. But you can further break down each minute into 60 parts, and that we call seconds. So just like how we break down 1 degree a while ago with 60 different divisions, you could take one of those divisions, which is what we call a minute, and break it down further into 60 compartments. And each of those divisions is what we would call second. So let's look at a typical measurement. So on screen, we have exactly halfway between 0 and 1 degree. So on this, you will notice that it shows 0 degree, 30 minutes, 0 second. And that is because that red line is exactly halfway. But if I were to go 1 minute beyond that, then that would now be 31 minutes. However, between 30 minutes and 31 minutes, you would have had 60 different seconds. If I was to the second to last second before I go to the 31st minute, then that would be read as 0 degree, 30 minutes, 59 seconds, and then 1 second more will take you to 31 minutes. Am I losing anybody?
No, sir.
We're good, sir. We good.
Huh?
A little familiar with it from land surveying, sir.
Okay, good. Likewise. So if you were to go to 59 minutes and then you have 60 division, the second to last stroke would be 59 minutes, 59 seconds. And then 1 more second would bring it to 1 degree. So I just want everybody to understand that. Let's look at some surveyors report now with some diagrams for some surveyors report. Let me zoom in a little on it so you can see a little better. Let's say I was drawing this thing and I'm going to start at the left-hand side of it. And I'm going up towards the top. Because the angle is between north going up and east going to the right, we would say that this angle is northeast 35 degrees. The length of the line is 100 feet. That's the side, that property. All right, so I want somebody now to read the next angle going down from the top to the right to tell me what it is. One person. Read and tell me what the distance and the angle is of that line. Anybody?
Sir, is it southeast? Distance is 130.
But you need to tell me the angle. You just said, right, so you say southeast 45 degrees. It's actually 0 minutes and 0 seconds. So we don't have to bother say the seconds and the minute if it's 0. All right, the other one would be going this way.
The southwest 80 degrees, 0 minutes, 0 seconds, distance 85.43.
All right, and then the last one.
Northwest 55 degrees, 91.92.
Great. All right, so one more example. We'll zoom in again. I'll take this one as degree, minutes, and seconds. If I turn upside down, I'll read this one. So this is actually 946.79 feet long from point 1 to point 2. And the angle is northwest, 58 degrees, 42 minutes, 45 seconds. Read the other one for me, going 2 to 3.
Sir, how would you set drawing limits for a land this shape?
You'd have to know the overall size and then you set your drawing limit. But remember, nothing is wrong with drawing outside of your drawing limit. It's just that when you zoom all, a part of it might be cutting off the screen. So you normally would set a drawing limit so you can accommodate first. But nothing is wrong if part of it drawn outside the limit, because when it's time to print, you can print whether you want to print inside or outside the limit. But if you know the size of it, you can just set up. Because I don't expect you to go change your drawing limit for your drawing now. We just only set the drawing limit only to accommodate our floor plan. Everything else that was drawn after that was drawn outside the drawing limit, and that's fine. If I was drawing the surveyor's report diagram alone, then I would just set a drawing limit for that. But you normally just start with your first drawing limit for your first drawing, and that's it. Everything else draw outside, that's fine.
Okay, sir.
So 1 to 2, what's the angle?
North,
Sorry, not 1 to 2,
east,
2, 3.
33 degrees, 5 minutes, 4 seconds, length 1146.60.
All right, great. So you get the idea. Now in our case, now this is an example of what a surveyor's report look like. This is like the cover page. Let's talk you through briefly on that. Now, when you purchase a piece of property, well, we don't call it a piece of property. It's called a parcel of land. You would have to get somebody who is called a commissioned land surveyor. Commissioned land surveyor would be a person who is licensed to practice, just like how you have a licensed electrician, who is the person who would pass the building. They would look at the building before it is passed by the general engineer, by the JPS, so that it could reconnect your light. This licensed surveyor is the person who's called a commissioned land surveyor. So this person now was the person who prepared this report. So it's telling me that this piece of land, which is a parcel of land, is located at the address that you can see there. However, every parcel of land that exists has something that I'm going to use a word now to represent it, called a serial number. However, that serial number is using two numbers. One called a volume number and the other one a folio number. So if you were to go to tax office or land agency and give them the volume number and the folio number, they could tell you exactly where this property is located. They can tell you the history of the property, meaning who owned the property, how many persons it has passed down to when it transferred from one owner to the other. They'll be able to tell you if outstanding tax is owed on that property and if it is up to date and all of that thing. So the volume and the folio number is like an identification number that is used to locate or identify every parcel of land. So first, the surveyor's report will tell you where it is located. It will tell you who has ownership of it. And then now, the next stage will have what is called the diagram, the surveyor's diagram. Now, this one was really a subdivision. So if you notice, it has 1, 2, 3, 4, 5 lots. So this person had a piece of property and they wanted to subdivide it into smaller lot size. Now, usually persons are interested in lot 3. So let's talk about lot number 3, which seems to be the biggest one. So you're going to tell me now, I want to know, because to draw this, we're going to start at peg 127 and go around and come back at peg 127. What I want to know, if these coordinates over here, these bearing coordinates, represent drawing the shape going clockwise or drawing the shape going anti-clockwise. So it says from 127 and the last one says to 127. So you tell me now. The first one says northeast 65 degrees 36 minutes and 11 seconds and the length of the boundary is 40 point something meters. Does that represent the line going up from 127 or the line going down from 127?
Sir, up.
Up. Good. So it means that the property is drawn, in this case, you're going clockwise. And then the other one will be the southeast and the southwest and go right back to the same point, which is northwest. Now, our property, basically, we are going to have this as our shape. So this is our building. We're going to put on the property later on. But we'll begin by drawing the property. So here we have the boundaries. I have these little circular symbols to represent where the corners are. So the length of this property starting at the lower left-hand corner going towards the right bottom corner. The length of that is 2,000, sorry, not 2,000. It's 29,000. That's millimeters. That's 29 meters long. So it's going from here to here, 29,000. And then it goes up 17,370. So we can easily draw these two first property line with the ortho, because this one is going dead east, horizontal, and this one is going dead north, which is vertical. And then afterwards now, we would have to turn off the ortho and be able to draw this boundary. You notice this one is going between north and west, so it's actually northwest. The angle is 81 degrees, 36 minutes, 46 seconds. Now the way how you would draw it, you remember polar coordinate that we did early in the semester, where we give at, distance, and then we give the angle. So what I've done is to give you a sample angle to tell you what you would type to draw this boundary. So let's review that. You would basically put, so while you're in the line command and you reach here, so with the ortho off, you would type at the distance travel, which is 24,596, angle, N for north, 81, and then letter D. Of course, it is not case sensitive, so capital R common. So letter D, because there's no symbol on your keyboard for degrees, so you would have to use the letter D. And then 36 with the apostrophe, 46 with the close quotation, not apostrophe, but close quotation, and then W. When you press enter, it will draw that line from top right hand corner to top left hand corner of the property. And then we will just do C, enter to close. So that's the first thing we are going to do. We're going to start drawing up the boundary for the property. But there are a few things that we need to do first. So let me jump to that slide where it gives that instruction. I think I actually canceled that screen by accident. So I ended the presentation. Let me reopen it and go to the page that I really want to focus on. All right, so let me just share that screen with you. All right, so this is the screen that we're going to be working with. This is a screen that we're going to be working with that tells us exactly what to do. So we have 3 things to do to complete this shape. So I will demonstrate, and then I'll give you some time. We can talk you through while you're doing it. So we are going to be setting our layer current. We're going to go in and do our survey as units. And then we're going to start with the line command and draw the boundaries. First 2 with ortho, last 2 without the ortho. Okay? So I'll go back to my AutoCAD screen. All right. Good. So step 1, we really want to change our layer to C boundary. Also, because this drawing is going to print at a scale of 1:100, our annotations that are annotative will be affected. So we're going to set our annotation scale to 1:100 so that the dimensions will scale up. Our title, which is also annotated, will also respond to that. And the line types, more importantly, will also respond to the scale. So that's the layer and that's the annotation scale. The other thing now is the units, which we are going to set to surveyors. So surveyors units. And then the precision is not the first one because this is to the nearest degree. The second one is to the nearest minute. The third one is to the nearest second of a minute, of a degree. The fourth one is to the nearest milliseconds, hundreds of milliseconds, thousand of a millisecond, and 10,000 of a millisecond. So we are going to stop with the third one, which is to the nearest second, and then click OK. All right, so I'm going to give you some time to do those 3 things, and then let me know. So it's going to be your layer, annotation scale, surveyors units with your precision. Do that and let me know when you're ready to start drawing.
So, sir, for the final assignment, the site plan and other plans should be on one page or a separate page?
Same page, but I'm not going to give you a site plan. You can just draw. If you want to use back the same site, if it's big enough, that's also fine. Or you can increase the length of the boundaries. So you will just draw your own site. The only way I could give you a site is if I'd given you a set size building, and I would ensure that the building can fit on a certain size property. So I'm not going to be hard and fast with that. You can just create your own site. If you want to make it whatever shape, you do it. Rectangle, square, polygonal, whatever the shape you want. That's okay. As long as you adhere to the principles and what's supposed to be on it. So you're using this one as your guide.
Sir, for units, you're supposed to go clockwise? Or
No.
leave it?
Leave it. Remember that for surveyor's unit, it goes both directions. It's going both clockwise and anti-clockwise because 0 is at north and 0 is at east. Sorry, north and south. You don't need to trouble that. It will work both ways. All right, so let me know when you do the layer, annotation scale, surveyor's unit with your precision down to the third one, which is to the nearest second of a degree. Tell me when you're ready. How are we?
Almost finished.
Finish, sir.
All right, good. All right, so what we will begin to do now is start drawing the property. So I'm going to turn on my ortho and pan the drawing over so I can get some space. I'm going to have a roadway beside it, so I don't want to draw it too close so it clash with any of the previous drawings. So I pan it over. It's going to launch the line command, so L enter. I'm going to pick a point to represent the lower left hand corner. And then my first property, I'm going to go from west going towards east, and the distance is 29,000 millimeters, so enter. Then I'm going to go up, going to north, and the distance is 17,370, enter. Then I'm going to release the ortho and start typing now that angle. So it's at the distance 24,596. Now you have two options. You can either press the tab key to jump over there to put in the angle, or you can do shift comma, and notice this is the same as less than, and then you're going to start typing the angle now. So it is N, which means north, and nothing is wrong. You notice when I type the N, the angle symbol disappear. Nothing is wrong with that. It's still accounted for. And remember, it's not case sensitive, so capital or common N, it doesn't matter. So N, 81, D for degrees, 36 apostrophe, it's 35. So 36 apostrophe, 46 close quotation, and then W for west. And then you press enter. And the line would have been drawn. And then I'm going to just type C for close, enter. So that is the property line. I'll give you some time to draw that, starting now. So go with your line command, L enter. Pick your point on screen, pull east, and your distance is 29,000. Let me put up the drawing on screen with the measurement so you can jump between your screen. We have 10 minutes to finish this first section before we get cut off again. So let me put up back the diagram with the measurement. So you pull right, 29,000, enter. Pull up, 17,370. Turn off your ortho and type what I have on screen at 24,596, angle, N, 81D, 36 apostrophe 46, close quotation, W enter, and then C enter to close. Let me know when you get there.
Yes, sir. Don't deal with.
Okay, Shaquille,
Yes, sir.
you
Yes, sir.
finished?
Yes, sir. So these are call them again, hidden lines.
There, remember that the layer was already created called boundary. It had a line type called border. So
Border.
it's a series of two long dash and then a dot, and it continues like that.
Okay.
Okay. All right, so we're gonna pick up with the next step now, and that is to create the sidewalk. So the distance from the boundary to the road, 900. So it says we're going to set the C road layer current. There's a layer called C road, and we're going to offset it in the current layer at a distance of 900. There's two boundaries we're offsetting, the south boundary and the west boundary. So we're going to offset 900 for the sidewalk and then 6,000 for the road width in both of the on both roads. So let me demonstrate that, and then you can do it as well. So there we go. Set my layer current called C road. And then we're going to offset in our current layer. So that's O, enter, L for layer, C for current, and then the distance is 900 first. So offset these two boundaries, 1, 2, and then enter, enter. Change my offset distance to 6,000, enter. Offset this one below and that one over. All right, so go ahead and do likewise. Offset the 900, then the 6,000, south and west boundary for those two roads. Okay. Let me know when you're finished.
Finish, sir.
Okay, great. Our next move is to basically create those boundaries now. So we know that the road goes way beyond where it would stop there, but we just want to draw a portion of it. So we want to create 3 boundary lines just to extend those roads to. So we're gonna create 1, 2, 3 boundaries, after which we're going to extend those lines to the boundary. All right, so we're just going to draw 3 random lines, same way in the road layer, and extend the lines them up and down and across. All right, so let's go back for that. So I'm going to start with my line command. Draw a line. Make sure when the lines are drawn, they are long enough so that if you extend the lines, they will intersect or they will meet. And then the one down here, because I'm going to have a curve, I want to ensure that I have enough room so that I can get the road curving around right here. So last boundary will be out here. And then we're going to use the shortcut extend, EX, enter, enter. Extend these 2 lines going that way. Extend these lines going down. Extend those to meet. And extend these to meet. After which we just trim out here. So I'll give you time to catch up to there. 2 minutes and it disconnects. So I expect by the time you finish up to that point, we'll be reconnecting. So go ahead and do up to that point. So just create your 3 boundaries, extend the line to them, and then you trim out that intersection. Just let me know when you finish up to that point.
Yes, sir.
All right, great. All right, the next move then would be to erase these boundaries, 1, 2, 3 of them, and we're going to put in the long break symbol. You remember that long break symbol that we used when we were, the break line symbol when we did the footing detail? You remember that?
No, sir. I remember the break, but I don't know about the long break.
Well, it's the same thing we call break line symbol. So
okay.
What's going to happen? This zigzag looking thing here. Right?
Oh.
So we're going to set the size. The gap now is the size. From here to there, 3,000, and the extension, 1,000. So we're going to do that, and then I'll put at the 3. It's less than a minute, so let me just demonstrate that you can go and do it during the disconnection, and then we'll resume. All right. So go back to my AutoCAD screen. I can quickly demonstrate that before the time goes. So you would go to Express Tools, where you find break line symbol, and then you would use your size. So you do S, enter, and you're going to make that 3,000, enter, and then E for extension, enter, and the size is, the distance is 1,000. All you need to do for each one is pick endpoint here and endpoint, and then you press enter. So you keep doing the same thing